Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Mitigating Risks in Software Supply Chain Security, brought to you by Sneak. We have a great webinar for you today, but before we get started, I need to go through some quick housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it again. We'll be sending out a link to access webinar on demand, or you can visit devops.com/webinars. We want to hear from you, sir. So please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. And joining me today is Mick McCauley, Field Strategist with Sneak. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Awesome. Thank you, Julio. Great. Well, I'm excited to actually get a chance to talk with everyone today and cover our topic, mitigating risks in software supply chain security. As Julio said, I'm Mick McCauley. I'm a field strategist at Sneak. I think we've got a lot of information that I'm excited to walk through, start some discussions, dialogues. Definitely looking forward to any questions you might have. To get started, let's look at what we want to cover today. I've actually taken this concept of the software supply chain security, broken it into a couple of different buckets. One of the things that I wanted to do was to make sure as we dive into the topic, right? Software supply chain security, what it is, the risk associated with it. Figured we would start with level setting. Let's understand, why are we even talking about the software supply chain? Where did it come from? What was the origination? Why is it a new thing that we're actually talking about? Then we'll actually get into some of the definitions, making sure that we're all kind of talking, about the exact same thing. What is it? What does it entail? What are the components that make up today's software supply chain? We'll then jump into a little bit more of the, why security? Like why are we talking about the security of the supply chain, the software supply chain? Get into some of the details of some recent news and look at some of the attacks that are occurring. We'll dive into some of the details associated with risks within that software supply chain. And then we'll take a couple of steps and say, well, what can you do about it, right? What are some of those approaches that you can leverage in order to address and mitigate some of those risks that we are seeing today? So with that said, like I said, I'm going to take a step back. We're going to start from square one. Why are we talking about the software supply chain? And some of this, a little bit of Captain Obvious here, but I wanted to make sure, again, we level set sort of the origins of this. And, I've got some logos on the screen, as you can see. And a lot of this was to emphasize the fact that we're in a digital world, right? Like an aspect of every part of our everyday lives is encompassed in digital, from personal interactions and things that we do, scheduling doctor's appointment, I schedule haircut appointments, getting groceries, the vehicles that we drive, the solutions that we use, but also back-end infrastructure, right? We've all heard about the power grid, and even modern day medical devices are using applications. So the explosion of all of these is helping to contribute to some of the reasons we're talking about this today. And taking a step back into history, I have a quote on the screen right now. And the interesting aspect of this, if you've seen it or haven't seen it, it's actually over 10 years old. This is a quote from Mark Andreessen, who penned an essay in the Wall Street Journal that was bringing everybody's attention to the fact that the applications and software are starting to consume the world, right? Almost every modern day business now has some sort of software application associated with it. The interesting part to me is when this was written, right, back in 2011, that's the exact same year Uber was just starting to publicly launch in San Francisco its ride-sharing app. Just a couple of years later, Grubhub just started testing food delivery. And even a couple of years prior to when this was published was this novel concept of My Locations inside of Google Maps that was just being released. Since that time and over these last 10 years, there's been this massive explosion. And all of those applications and the ability to do business in different ways and take advantage of that and the efficiencies have led to this need for all of these applications. That need is also where we saw some changes in the processes in which applications were being created. And this is kind of that foundational element that I wanted to start with, say, so with that digital revolution and that requirement for rapid application creation and changes in development and practices, we saw an evolution of what, in the very early days, and I was actually part of this, quite a few years back, but saw how, some of the original applications were being created. You had developers within your organization. They were inside of your perimeter. They were writing the code. The code stayed inside your perimeter. The code itself was brought together by the development teams on a build server, compiled. It was bundled up and put into components that was then delivered to the IT operations team, which would rack servers, build the infrastructure, take the application to deploy those applications within that entire perimeter, and usually in those data centers. We've seen that change substantially to modern application development. And arguably there is no perimeter, right? Even the developers may or may not be inside of your walls. But in addition to that, in order to take advantage of some of the efficiencies of modern DevOps, right? The ability to write code, distribute it out to your consumers, get feedback, take that feedback, implement it into your code in a very iterative, fast process. There's been changes to some of those traditional processes in order to achieve that. That has led to this very large ecosystem that contributes to the delivery of that software. This is the origins of a software supply chain. Now you have many different third-party assets, components coming together in order to help you deliver those applications. So that's a little bit of the history, right? Why we're actually talking about it. So now let's get into some of the details of what is it, right? What does it entail? And this is where, again, I want to use a little bit of analogies and simplify it. Then we'll drill into the details specifically associated with software. But the concept of a supply chain isn't new, right? It's not something novel. And the components that you see on the screen are applicable to the software supply chain. Now, I picked a physical one because it's easier to kind of visualize and imagine. But if you look at all the components that go into creating a product and the supply chain associated with it, you can see in here, you're going to start potentially with raw materials, the steel, metal, plastic, whatever components that you need in order to create your product. You might also have suppliers that are contributing to that process, right? Like they're going to build components for you that you're going to source and use to create your own. An interesting aspect of the suppliers piece is they also have their own supply chain, right? They've got their own processes very similar to what I'm showing you here, in which they're actually creating the products that they're delivering to you. So nested supply chains associated with it. You've got the employees, you've got the tools that they use. Even the tools are probably being manufactured by other organizations. You got the manufacturing itself. And in cases of different types of manufacturing environments, you may have manufacturers leveraging machines, right? And those machines were created by other organizations and businesses. And so again, supply chains there. So you start to get this nested sort of interaction associated with the supply chains until you build your product, you have this distribution mechanism, ultimately delivering out to your end customer. That's just a standard supply chain, right? And so sharing those concepts. And the one thing though I wanted to talk about was, why is understanding that interrelationship important? And looking back at some historical examples of why being able to understand that supply chain have become critical, there's a few examples that we can talk about to illustrate that. One of them is in 2006, there was an E. coli outbreak related to some spinach. It was interesting enough, started in the upper Midwest, and where there were some illnesses that happened. The CDC, FDA got involved, started doing some investigation. They were able to understand that the individuals that had felt ill had all had something similar in that they had consumed some spinach at some restaurants. As part of that investigation process, they were able to trace it back to those restaurants, understand the distribution of where that originated from and the manufacturer associated with those, and then even able to trace it back to the originating farms in which they were harvested in order to understand what caused it, where did it originate, right? So that understanding of that relationship and actually some of the documentation associated with it were critical in understanding the impact of everybody else that might be exposed to this and understanding the impact of what actions needed to occur. You can look at other examples. I'm sure many of you on here have probably been involved in some sort of automotive recall, right? Where there's been some safety concern that was discovered. And as part of that process, once it was discovered, they had to figure out how it happened, why it happened, what caused it, and be able to go through those supply chains up to the other supply chains in order to find those, figure out how to fix it, and then also understand all of the other products that were actually affected by those in order to ensure that the fixes were delivered appropriately. If we take those concepts, right, and we apply them now to a digital world, to this software supply chain, we can start to see those different components. And the same thing applies here from a materials, tools, platform, processes, right, that are used in order to create these end product software or applications to consumers. If you get into some of those details and you start in the far left, you can see we've got developers, right? The employees, they're actually creating the applications, have the ideas. They're leveraging their own tool sets, the IDEs, their desktops even, as mechanisms that are part of that software supply chain. Any modern application also leverages open source libraries, right? These building blocks of code that developers don't have to recreate every single time that they're creating applications. There's this huge abundance of libraries that are made available that you can use. Same thing with containers, right? This pre-codified version of an operating system, which helps streamline the process of delivering applications built on top of these operating systems so that you can push them to these production environments in a very, very quick way. All open source, made available, building blocks, right, from different sources that are being brought in and built upon. If you look at other areas, the code repository is potentially a third-party system. The build process itself, right, all of the different components, the compilation, the build, the unit test, the deployment to different servers. In a lot of cases, in order to do that effectively and extremely fast, organizations are leveraging third-party software solutions to help them facilitate that. All of these components, even these third-party elements, the containers, the libraries, they also have their own sort of software supply chain. All of these contribute to building that artifact, makes its way to storage, some either cloud environment or the end product, and then delivered to the end consumer, whether that's another business or the end user themselves. Those are all of the elements. And so when you start to look at everything that comes together in order to create that, you can see how that ecosystem that I talked about before has become much larger and has a lot of outside influence that it didn't have historically. So why are we focusing now on the software supply chain, right? What's brought it to everyone's attention? And a lot of this is dictated by the headlines that we're seeing, right? The attacks themselves. And so if we drill into, well, why are these attacks occurring, right? What's the driving reason behind them? You can almost put them into a couple of different buckets, right? Some of the reasons behind it. One of the first ones is, it's the weakest link. In some cases, within organizations, there's been a tremendous amount of focus on how do we secure, if you've got a cloud native application that's running on the internet and exposed to the world, a lot of focus on securing that, right? Secure the infrastructure, secure network access, permission and controls, anomaly detection, monitoring behaviors. But the process and the approach to actually creating that application may not have as much as those stringent controls associated with it. Since it doesn't, it becomes one of the areas to actually attack and one of the weak links that make it very attractive for attackers. The second one, and this is a very intriguing one, is this idea of attack once, infiltrate many, sort of a cascading attack, right? And the idea here is going further up the supply chain. And if we look at some analogies here, right, there's a couple of different things that you could look at. One of those, if you took kind of a military view, right, there's the ability to directly attack your enemy, another set of armed forces. However, what you could do is, in order to create weakness, right, or perform a different type of attack, is to go to the supply chain that supplies them, right, like attack their resources in order to weaken the strength of your opponent. However, you could take that a step further, right? Like let's say that supply chain is protected very, very or guarded very closely, and so it makes it difficult to penetrate. You might be able to go upstream even further. And if you think of this in again military terms, if you think the ammunition that's leveraged by those, maybe you go to the originating factory that actually creates those, and you can infiltrate that and maybe manipulate the gunpowder there, make it non-effective, swap it out for cinnamon, something that's non-explosive, or make it even more explosive. And the idea there is, the further you go up, it could have other effects downstream. And if you look at that example, if I was able to infiltrate that ammunition manufacturing, anybody that consumes it, not even just the enemy I might be concerned with, is affected by that. So you have the ability to have much broad effect associated with what your attack may occur. Same thing if you look at the physical manufacturing industry. If there was, you were wanting to target some specific organizations, if you could figure out some similarities or things that they use that are in common, in manufacturing, very often robotics are used. If all of the manufacturing companies leverages the same robotics products and company, you could go launch your attack against them, infiltrate those, and so the subsequent downstream consumers of those can become your victims as well. So that's cascading attack is one of the things that we're starting to see. With that in mind, right, Gartner also predicts that within just a couple of years, we're going to see a 3x increase in the number of supply chain attacks that are occurring, and 45% of organizations across the globe are going to have some sort of a supply chain attack. With that said, let's look at some modern examples of where we're seeing that today. And so if we look at all of these different components that we talked about, the developers, the operating, the open source libraries and containers, the build environments, in a lot of organizations, depending upon the freedom and agility, there's many different solutions here. And so it makes it more complex to understand, right? There's this implicit layer of trust when you're bringing in all of these outside elements, assuming that everything is secure associated with them, that you're inserting into your own pipeline. And then again, because of the security associated with it, hasn't always been as focused strongly in the supply chain as the end product. It's again exposed to potentially a weak link. Looking at a few examples, we've seen many different types of these attacks occur. The open source libraries, right? There's been some recent ones, and you can look these up. There's some attack vectors called dependency confusion, where attackers were able to discover that very large organizations were naming some of their internal private packages with some naming conventions, were able to go create code, put them into these public registries, and have those mistakenly downloaded based upon the way the processes were in order to get their code embedded inside of these organizations' end result applications. There's an attack vector called typo squatting, which is if a developer says, I want to use this particular open source package, and they happen to transpose a couple of characters, type the wrong character. There's attackers that are creating alternate versions with those typos embedded in order to try to trick them into actually using and consuming those with malicious code, right? The end result being that either I'm attacking the organization or I have other sort of focus areas. Similar type of attacks on the container side, right? We've seen some examples where There's been some malicious actors that went into some public containers, published their own, right, in order for everybody to consume, that contain crypto mining. And in this particular case, the target of the attacker was simply to steal resources, right? Monetize what the attack was able to deliver to them. So if they could get organizations to consume the containers, they got published out into production environment, they were siphoning off those computing resources in order to execute that crypto mining. Developers, right? The developers are just, they're people, they're individuals. They are contributors to creating these applications. We've seen examples of, in this case, there was a Visual Studio attack that was carried out by a set of attackers that used social engineering, a little social media in order to influence these developers to convince them to collaborate on some research about, interesting enough, some security associated with some code. When those developers use the sample code set the attackers were trying to get them to install and opened it in their own IDE, it installed some malware which created a command and control server, which then allowed them access to anything else that that developer had access to. Pipeline attacks. We've seen a couple of fairly substantial attacks on the pipelines themselves. There's been a couple instances, one very prominent that I'm sure everybody's probably heard of. Two of these examples, the CodeCov and the SolarWinds, these were examples where either due to some weaknesses, flaws in how things were created, the attackers were able to go into the systems that these organizations were using in order to create their software. So these were attacks on their specific pipelines, right? Infiltrating the process in which the applications were being created. However, the interesting aspect of these attacks were the end game wasn't to attack those specific organizations. The end game was to create one of those cascading attacks. I can attack that pipeline in order to infiltrate what they're creating, put my own malicious code inside of their software in order to ensure that it gets published out to their consumers, and then I can use that as my attack vector to the consumers of those applications. One of the interesting aspects, there's a couple of things that I wanted to touch on in here, is due to the fact that this is all digital, right, different than the physical world, these attacks in the distribution can happen globally within a matter of a few minutes to a couple hours, right? Like I could launch one of these attacks, infiltrate some code. Current organizations are updating and publishing code continuously every few minutes. And so very quickly I can have impacts associated with those attacks, which have larger sort of impacts around the globe. The other interesting piece too is there's a difference between an attack, right? An attack on the pipeline versus a vulnerability that's introduced. It's still a risk, right? These are risks, and I'll throw out an example because you're not seeing it on the screen here now. Is Log4j. It was a open source library that had a fairly substantial weakness in it, right? The ability to attack and take over the server. And so that vulnerability was introduced through the software supply chain, right? It was a risk that was introduced into the code, which ultimately got published, right? Which meant that that weakness was exposed to production. A little bit different than a direct attack on the pipeline, but it definitely was a risk that was delivered through that pipeline. With that said, this is also these attacks, right? They're starting to get much more visibility and scrutiny. You know, if in the United States, there was an executive order that was published just a little less than a year ago, which put a focus on this, right? How do we ensure that those software supply chains are controlled and locked down as much as possible? And we're going to see even more scrutiny on this as we continue. So what do we do about it, right? Like we've got these risks. We've had this entire ecosystem that's used to create software. We have these directed attacks that are occurring in order to exploit those weaknesses. What can we do? And more importantly, before what we can do is where should we focus, right? We talked a little bit about the complexity associated with that software supply chain. And if we start to look into the areas of risk, you can put these into different buckets. Now, there's different ways you can organize and categorize these, but when you look at them, you can easily start to identify where are some of my risks, where are some of these attack vectors that can occur. And the first one is you have dependencies, right? You're bringing in components from the outside world that could have malicious attacks embedded inside of them, right? And vulnerabilities that could be used to abuse some of those elements in order to exploit those weaknesses as part of the pipeline process as well. So the app dependencies, the libraries, the containers are one area. There's also the pipeline itself, right? The pipeline, how you're actually creating these potentially has weakness as well. There's the end user, right? We're all human. The developers themselves. The code repositories very often are third-party environments that you're licensing from other organizations. The build pipeline, the process, the security associated with it, the access controls, SSH keys to those code repositories, all potentially expose access to information that could lead to a supply chain attack. In addition to that, not only are there the open source libraries and containers, but there's these supporting dependencies, right? Even software applications that are being leveraged inside the pipeline where there's some implicit trust associated with them, right? There's this assumption of security embedded in there that when you bring them into the pipeline, that they're not exposing you to some of those attack vectors. All of these lead to what we just talked about, right? The potential to bypass some of those security measures which you'll have in production. And then also, when you look at that software supply chain, the enticement of the ability to have that cascading effect. So what can we do, right? What are the steps that we can leverage in order to help, mitigate some of these risks? And so some of the actions that we can start to take is to leverage some of the security frameworks that are out there. And I'll talk about these, and then we'll dive into a couple other more software supply chain specific approaches, right? Some solutions that are being created by the community that can help provide some guidance associated with steps that you can take. First one is this: if you're leveraging inside of your organization today any sort of security framework, like the foundation associated with that most likely can be applied to the software supply chain. There's no reason you can't implement access controls, zero trust type of approaches, getting the visibility of understanding every single risk vector that is there, right? So a lot of these have generic applicability, which you can start to leverage. And in some cases, the NIST framework of identify, protect, detect, respond, recover, they've actually even taken that a step further and taken that framework and created cybersecurity supply chain risk management processes based upon that, again, in order to provide some guidance. In addition to that, like the open source communities, right? The Linux Foundation, sponsoring OpenSSF, the Open Source Security Foundation, the Cloud Native Computing Foundation, right? These organizations are also starting to look into, like, how can we help and provide guidance to organizations on how to solve this? Sneak, and we'll share some of the details of saying, like, we've put together some focuses of saying, here's some quick guidance on some things that you can start to implement right away in order to help secure your pipeline. The NTIA, as part of that executive order that was released, one of the things that it just put a focus on was the software bill of materials, right? Like, this is one step to understanding that pipeline. And I'm a huge proponent of this, right? Because there's multiple sort of things that fall out of it. First one being, it's a great documentation mechanism, right? Understanding when you're creating an application, what are all the components? What are the ingredients inside of that? So you understand at any given time what's in there, so you can cross-reference that against any sort of known risk to understand what risks you have in your current application. It's also a phenomenal communication mechanism. When you need to create applications that are shared with other organizations, being able to share with them exactly what's embedded inside of it so that knowledge of the risk is shared with those organizations is exactly what this is intended to achieve. Now, this is a ingredients list, right? It's all of the components, and it's meant to be a good documentation and communication mechanism. However, it's not specifically going to stop supply chain attacks, right? It helps to provide information about what risks are in those end focused deliveries, but it's not necessarily, helping to address yet some of those elements associated with the supply chain risk. If we look at, specific guidance associated with the software supply chain, there are organizations, right? This is part of the Open SSF, and that is being sponsored again by the community, sponsored by the Linux Foundation, where there is a project that's called, nicknamed SALSA, right? That stands for Supply Chain Levels for Software Artifacts. And they put together this framework, this approach to look at your software supply chain in order to identify and kind of segment out different areas, and then steps that you can take in order to help put security into those processes. And you can see how, they've started to segment their areas out: the source threats, the build threats, the outside dependencies, and even a quick glimpse into like that segmentation. Interesting aspect of this is they built this framework so that you can pick and choose which areas of risk you want to focus on, and then slowly improve that with additional sort of steps. The Cloud Native Computing Foundation, right? They've taken the same sort of approach to say, how can we provide guidance to organizations on steps that they can leverage, right? In order to help provide some security. They've segmented out into slightly different categories as well. How do you secure your source code, right? The raw materials, the build pipelines themselves, the artifacts that are created, those deployment processes, and providing some guidance associated with, again, steps that you can take in order to help ensure that there's less exposure associated with it, and help to offset the ability for attackers to actually take advantage of those weaknesses. From a sneak perspective, we just published this cheat sheet. Actually, inside of the webinar today in the handouts, we'll make available the link to this, both a white paper as well as this cheat sheet, in order for us to say, here are steps you can take as well, right? Like, let's look at all of those components, similar in nature to the ones that I just shared before. And if you look at some of the details in there, we start to focus on, like, how can you understand your risk, reduce your risk in all of these different areas, looking at SBOMs, protecting your code, doing some inspection on your code, whether that's security testing, as well as leveraging principles such as, the 4 Eyes principles to inspect and make sure that, there's not something obvious and malicious being injected in there. Looking at infrastructure as code, making sure that, you're not setting yourself up to have exposures later in the life cycle. The pipelines, right? Best practices on pipelines of how can you start to put steps in place that make the ability to attack it much, much smaller. And then one of the probably more powerful and important aspects that I wanted to leave everybody with was, as part of all of this, right? We've talked about how the software supply chain came to be, how it changed from this very sequential sort of handoff inside of a perimeter to this massive ecosystem leveraging many solutions and tools, to the modern DevOps process with this highly agile, quick to release ability to create applications. Part of that transition to that modern process, right, that modern DevOps, was the fact that in order for it to occur, there was a collaboration that happened, right? You had developers, you had IT ops, and it created this whole idea of DevOps. That occurred because they were able to communicate and share what was needed, what works, what doesn't, what enables that process to be very, very effective. The frameworks and the details and the steps that I just shared, you could pick the best framework for your organization. However, it's still going to hinge on the collaboration that's being used in order to implement it, right? Understanding if you're going to put steps and procedures and checkpoints and tests and lockdown environments, you need to have buy-in with everybody that's involved inside of that process. You need to make sure it can be adopted, that there's education, awareness, why it's being deployed, what are the requirements, right? The responsibilities of the individuals that'll have to actually use it in order for it to be effective. And you need to make sure everybody in the process is bought into that in order for it to truly be adopted and effective. This is probably one of the most critical aspects from a SNEAK perspective that we've seen inside of organizations in order to be effective, right? You can have the best solution, but you need to make sure you have mind share and adoption across the organization to have an effective process. With that, I want to say thank you for everybody that participated and listened in today. We'll still have a few more minutes that we can check on any questions anybody might have, any chat, but I would definitely love to answer any questions that are out there. Cool. I do see one. What do you see as the most difficult part of implementing a software supply chain security program? It's a good question. Actually, I think the very last part of what I shared is definitely a component of it. One of them is probably going to be understanding the landscape first, right? There's this concept, and these are where those frameworks are important, is you first have to have the visibility aspect. What are you up against? Where are those risk areas, right? That ecosystem could be substantially large. So understanding all of those elements that are part of that ecosystem in order to identify where the risk areas are. That has to be kind of that step one. Step two is then putting a plan into place of how can you now address those? And again, through the collaboration and cooperation of everybody in the organization, it's important to actually start to put that in place. Awesome. Any other questions that were sparked during the presentation? Cool. Well, I want to remind everybody that inside of the handouts section, we have published a link to a couple of those elements, one being a white paper specifically on the topic we just talked about, the software supply chain security, and then that cheat sheet that I flashed up on the screen and some of the details that we've released. Another quick question. What do you think of using value stream mapping workshops to facilitate collaboration between SEC and DevOps? Value stream mapping. The interesting aspect of that question is any sort of workshop. I think when you start talking about that establishes those lines of communication is probably going to be extremely useful, right? Like the ability to bring together those teams to say, here's what we're looking at, here's why it's important, in order to start to drive those conversations and say, okay, we get it. Like, what can we do? And then be able to say, like, that's going to be, too difficult for us to implement, or let's do this. And what if we were able to, try these different features and take steps and transition to that, as well as measuring the progress associated with those and slowly transitioning into some of those alternative approaches. So any of those types of things. So I definitely say workshops looking at those types of things will actually encourage those conversations. So those are extremely, I think, important. That actually starts a lot of that core fundamental communication, which when you start to implement those frameworks is key in order to be successful.
Hey, Mick. Just a quick reminder for everybody. We still have plenty of time for questions if you have anything. But I did want to remind everybody that today's webinar has been recorded. So if you missed any or all of it, you'll be able to watch it again. We will be sending out an email with a link to access the webinar on demand, and you can also find it on devops.com. Just look in the webinar section, and you'll find it there. And I did mention at the beginning that we were doing a drawing for $25 Amazon gift cards. So I'll go ahead and do that now. Our first winner is Patrice C. So congratulations. Our second winner is Brian V. Our third winner is Diego G. And our fourth winner is Sasha S. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, please check your spam folder. Okay, just taking another look at the Q&A. Doesn't look like we have anything else. Okay, so with that, Mick, thank you very much for taking the time to put this presentation together. Really appreciate it.
Absolutely.
Excellent. I'd also like to thank the audience for their time and engagement. This has been Julio Godinez signing off. Until next time, thanks, everybody. Take care.
Thanks all.